4 is all about translating back and forth between formulas, tables of data, and graphs that describe linear relationships. And so if I have, the idea is that if I have a linear relationship between two quantities, let's call them x and y, where maybe on our graph we'll depict x on the horizontal axis, y on the vertical axis, that the entire point of this topic is to be able to translate between a graph, the information that's carried in a graph of that relationship, back to the information that's carried in a table of data, so data points, ordered pairs that are part of this graph relationship. So for example, this ordered pair right here, 2, -1, is one of those listed in my table of data, but there may be a bunch more. And then translate back and forth between those two things as well as an equation that not only describes a few points, not only describes that portion of the graph which we can see in this viewing window, but this describes the relationship between all the infinitely many different x's and y's that are a part of this relationship. Those that we can see, those that we can write down, and those that we cannot. So of course, the most power is wrapped up in having a formula, because then we can do a whole lot more with it and not be tied to the specifics of what we can see in a graph or what we can see in any given data table. And so the question that I want us to talk about, just to wrap up this discussion, is of the following type. Let's take a look at this problem. This problem asks us to consider a line, y equals -5x plus 9. So they've given us, in this problem, a line to start with, y equals -5x plus 9. And they ask us a couple of questions, each of which is going to ask us to find an equation of a different line. Find the equation of the line that ... Right? And so each of these two problems is going to have a similar type of answer. Our answer is going to be an equation for a line. What makes them interesting is what they tell us about the equation that we're supposed to find the line of. And these two different parts give us two different tasks. In the first part, we're supposed to find an equation of a line which is perpendicular to this one, y equals -5x plus 9. And part B looks almost the same, just putting parallel here in place of perpendicular. So what each of these parts have done is they've given us a point, 3, 6, and they've given us a direction for the line that we're supposed to find an equation for. And all we have to do is put that information together to find an equation. So let me start by just asking this. What is the tool that we have that will let us, with information about the location and direction of a line, what tool or what template do we use to determine an equation for that line? What would you call it, or what does it look like? What's our end goal? What is the shape of our answer going to ultimately look like? Remember, every equation which describes a linear relationship needs to first of all be an equation. So we know we're going to have an equal sign. It's going to have an x and a y in it, which are the two quantities being related. What else does an equation for a generic line tend to look like? What are the elements? What's the template? What's the tool that springs to your mind whenever you answer a question that's asking you to find an equation for a line? If you don't have this tool, you're going nowhere in these problems. Slope, okay. So we know that slope is something that we're going to have to deal with. Slope is often, what letter do we usually use to represent a slope? M. And we have a tool in our toolbox that can tell us how to determine the slope given 2 points. In other words, if I want to compute m, if the information I have is the coordinates of 2 points, how can I find a value for m? Minus, right, so we're measuring the difference between two y coordinates and dividing by the difference between x coordinates. This is what we often think of, right, as rise over run. Right? It's the relationship between vertical changes and horizontal changes on a graph. So that tells us how to find a slope if the information that we have is 2 points. What I'm asking, I guess, is what is our final answer to the kind of problem that you're trying to solve here tend to look like? What role does that slope play in our final answer? Yeah, that template, y equals mx plus b, is usually the template and the tool that people reach for the most often in solving these problems, right? The slope-intercept form of an equation for a line. Slope-intercept. And so the slope-intercept form requires us to specify a slope, first of all. And when we know what our slope is, we're going to put it right there in place of the m. And what's the other thing that we need to specify for this equation in order to have a completed equation? The y-intercept. So if I know what the y-intercept is, I'll place that here in the b place, and then we'll be done. So that's the good news about finding an equation for a line, is it really only requires us to find two things. We need to find a slope, and we need to find a y-intercept. And as soon as I know those two things, I can just stick them into this template, and we're done. Right? And our answer is going to look like y equals something times x plus something, where the roles of those somethings are respectively the slope and the y-intercept. So let's think about the first of these two parts of the problem. The first part, part A, asks us to find an equation of the line. So that's the cue that we know our answer is going to look something like this. We just need to figure out what m and b are, which is perpendicular to this line and which passes through this point, 3, 6. So I always like to sketch graphs along the way because I think pictures speak 1,000 words or whatever. So here on this graph is the line y equals negative 5x plus 9, the one that's given to us in the problem. It's this one here. By the way, where does the number 9 show up on this graph? Where do I read the number 9 off of the graph itself? Where do I find it? What role is it playing in the equation? If this is y equals mx plus b, then 9 is the y-intercept. And sure enough, when we look at where this graph crosses the y-axis, it's at the point 0, 9. Great. So that's where the 9 shows up. What about 5, or negative 5, rather? Negative 5 is playing what role in this equation? It's the slope. And how would I know from this graph that negative 5 is the slope? Where on this graph am I going to find that kind of information? It goes down 5 when what happens? So let's say I start from this point and I go down 5 units. So that's going to take me down to, that's going to take me down to here. So going 5 units down. But if I go 5 units down on this picture, how many units do I have to go over? 1, right. So there's our definition for slope, right? Slope of negative 5 is the same as negative 5 over 1 as a fraction, right? And reinterpreting this as a rise divided by a run, that means that we're going to go 5 units down, because the 5 is negative, whenever we go 1 unit to the right. So there's our interpretation. So there's where the negative 5 comes from. There's where the 9 comes from. Now going back to the question we're trying to answer. The question has given us a point, 3, 6. So let's plot that point here on these axes. There's my point 3, 6. Just start from the origin, go 3 units to the right along the x-axis, and then 6 units up in the vertical direction. That's going to give me the point 3, 6. And what we're supposed to do in this problem is find an equation for the line which passes through that point, that purple point, and which is perpendicular to the red line. So first of all, what does the word perpendicular mean? What is it telling us about the line that we're trying to find an equation for? It intersects with the red line, and when it intersects with the red line, what kind of an angle does it make? Yeah, that we're using the word perpendicular means that these two lines meet at a 90-degree angle. 90-degree angle. So it's this purple line that we're supposed to now find an equation for, right? And that equation for the purple line is going to answer this question. And we happen to know that this purple line goes through the point 3, 6. So the big question is, what's the slope of this purple line going to be? And that's the one place where we get some new techniques, some new strategies for finding equations for lines. how do I find the slope, let me write it this way, of a line that is perpendicular to the line y equals negative 5x plus 9. Perpendicular to y equals minus 5x plus 9. So first of all, let me ask you this. What's going to be more important about the original line as far as figuring out a perpendicular? Is it going to be more important for us to know the intercept of the original line or the slope of the original line? Which one is going to be the one that's going to tell me about perpendicular or parallel? It's the slope. So this number, negative 5, it tells me the direction that this original line is going in, right? Down 5 to the right 1, down 5 to the right 1. And so it's the slope that we are going to care about. So let me rephrase this. I want to find the slope of a line which is perpendicular to a line whose slope is negative 5. So let's narrow down our focus here. I started with a line whose slope is negative 5, or if you like, negative 5 over 1. And I want to find an equation for a line which is perpendicular to that one. So does anybody remember from reading the section or from working problems like this in the past, what do I do to this slope, the red slope, to find the purple slope? Dina? All right, so one thing that I'm going to do is I'm going to take the reciprocal of the fraction. I'm going to flip-flop the numerator with the denominator. So take the negative 5, take the 1, trade places, get 1 on top, negative 5 on the bottom. Let's take a moment and look at that slope and ask, how can I tell just based on that number that I don't quite have the right answer yet? If I have a line whose slope is 1 over negative 5, what direction is that line going to be going in? It's going to be going downward. How do you know? What is it about this number that gives us a downward sloping or a decreasing line? Because it's a negative number, negative 1/5. And just based on looking at our picture, the purple line that we're trying to find an equation of is not in fact decreasing, it's increasing. So in addition to taking the reciprocal, what else do we end up wanting to do? Make it positive. Switch the negative for the positive or vice versa. So it turns out that those are the two steps that we need. We'll take the reciprocal and we'll also take the opposite. So it's both types of flipping that we talked about earlier in the semester. Flipping in the sense of multiplication to replace the number with its reciprocal, but also flipping in the sense of addition, that we're replacing a number with its additive inverse, its opposite. So we swap negative to positive, we swap positive to negative, whichever, and we also trade numerator with denominator. And it gives us the slope of a line which is perpendicular to the original slope that we wanted. So the conclusion here is that 1/5 is going to be the slope of this purple line. And so now here's the thing to remember, right? Is that once we've navigated that step, that perpendicular means that the slopes are opposite reciprocals, right? That they're flipped upside down and also traded positive for negative. Once we remember that, now we've really worked our way back to the following question. That our original problem is now to find an equation for a line whose slope is 1/5 and which passes through the point 3,6. Right? So now that we've done all of the sort of geometry involved in this problem, now it's just taken us back to the kind of problem that we were working on solving the last time that we were in class, right? That if somebody comes up to you on the street and hands you a slope, hands you a point, that you should have the tools at your disposal to find an equation of a line which now meets these two criteria. So let's do that part, and then that will wrap up this example. So we know that the line that we're trying to find an equation of in part A here is a line whose slope is 1/5. So how should I use that slope of 1/5 to make some progress on solving this problem? What should I do with that 1/5 here? Put it where the m is, right, exactly. That's the beauty of slope-intercept, is it's a template. It lets us just put in the slope that we want, 1/5, and now I've gotten half of my puzzle, 1/5 x plus b. So now I've used what I know about the slope, and the only thing left to do is somehow guarantee that my line passes through the point 36. Now, how do I do that? How do I require this equation, y equals 1/5 x plus b, to be satisfied for the point 3 comma 6? What should I do with that 3 and that 6? What's kind of the only thing I can do with that 3 and that 6, given this is the equation I'm looking at? Put those into the x and the y. Exactly. In this equation up here, it looks like it has 3 unknown quantities, y, x, and b. If I supply that equation with an x and a y, I should then be able to use algebra to find b, which is really the last thing that we need to do in order to finish this problem, find b. Right? So we will substitute 3 for x and 6 for y. And in doing so, 3 here, 6 here, we'll get an equation that we can solve for b. I'm going to do that just by clearing denominators, just for fun, to remind you of that technique that is, again, so underused. I'm going to do that by multiplying both sides by 5. That's going to get rid of my fraction. And on the left side, I'll end up with 30. Over on this side, I'll end up with 3 plus 5b. Hope I did that right. And now to get b by itself, what do I want to do first? Subtract 3. Takes the order of operations backwards. I'll get 27 equals 5b. And finally, divide by 5. And I find out that b is 27 over 5. I don't feel any particular need to change that into a decimal or a mixed number or anything. Just leave it as an improper fraction. And now don't stop here, because we have to go all the way back to say, what is the question asking us for? It's asking us for an equation. So our answer, our final answer, needs to be an equation. So we'll return back to this template, y equals negative 1/5 x plus b, and remind ourselves that the whole purpose of what we did just now was to find the value of b. And now, having found it, we can write, or rewrite if you like, our final answer. Y equals 1/5, that was our slope, x. Don't lose the x, by the way. Sometimes people will forget the x when they're writing this final answer. 1/5 x plus 27/5. And that's that. So every problem where we're trying to find an equation for a line generally proceeds along these same sorts of thought processes, right? We first start with this y equals mx plus b template. And we know that if we can find a value for m and find a value for b, we can just stick them in and be done. So then we go on the hunt for a slope and for an intercept. And for a slope, in this example, we use the information that the line had to be perpendicular to this one that we were supplied with. And perpendicular means take the opposite reciprocal of that slope. So negative 5 turned into 1/5, so we got our slope. Then we needed to know the intercept, and so we used the second piece of information, the information that this line has to pass through the point 3 comma 6. And at the end of all that work, we get this slope-intercept equation. And just to make sure that we got it, let's plot that with our graphing tool. Y equals 1/5 x plus 27 over 5. And sure enough, that line passes through the point 3,6, and when it meets the red line, it does so at a 90-degree angle. So it looks like we got what we were after.